If your sample size is too small, your study may miss real treatment effects and produce misleadingly negative results.
With a larger, well-chosen sample, your confidence intervals become narrower, so prevalence or mean estimates are general. In health research, too few participants waste their time and expose them to burden without clear answers.
Journals and ethics committees expect a sample size explanation, so good planning strongly improves your chance of publication. Today, we will understand what we really mean by sample size in healthcare and allied health research.
Sample size simply means how many participants or observations we include when we conduct a particular research study.
In allied health, it could mean patients in a trial, community members in a survey, or samples in a laboratory study.
Although it looks like a simple number, sample size strongly influences power, precision, and how credible your.
Good sample size planning begins with one focused primary question, not a long list of different outcomes. You select one primary outcome, like walking speed, pain score, or HbA1c, for the sample size planning. Next, you identify the design family, such as surveys, two-group comparisons, paired studies, or DUXA. Finally, decide if the outcome is continuous, a proportion, or time to event. Because most sample size formulas reuse similar ingredients: effect size, variability, alpha.
Effect size describes the meaningful difference you care about, while variability describes how spread the values are. Alpha controls false positives in your conclusions, and power controls how likely you are to detect effects.
Your design and expected dropout or non-response together decide how much you must inflate the base sample. Clinically important difference is the smallest change that truly matters to patients or clinicians in real life.
In allied health, it might be a 0.1 meter per second gain in walking speed after therapy. You can choose this difference using earlier trials, expert opinion, or patient-reported minimal important difference studies.
Choosing a smaller important difference increases sample size, so match ambition with what your team can manage.
For continuous outcomes, standard deviation shows how spread individual scores are, and greater spread. Do you usually estimate standard deviation from previous studies, local audit data, or a small pilot with similar patients? For binary outcomes, the calculator needs an expected proportion, such as anemia prevalence.
Proportions near 50% usually require the largest sample sizes because uncertainty is greatest in that region.
Alpha is the probability of a false positive conclusion, and we usually set it at 5%.
Power is the chance of detecting the chosen effect when it is truly present in the population. Lower alpha or higher power always increases sample size, so you must justify those choices carefully in protocols.
Two-sided tests are preferred in healthcare because effects can appear in either direction, expected or unexpected. For estimating a single mean, sample size depends on standard deviation, desired precision, and confidence level. For a single proportion, like anemia prevalence, we use expected prevalence, margin of error. A tighter margin of error, such as plus or minus 2%, always demands a much larger sample. Well-planned descriptive samples can strongly guide services and policy when estimates are precise and transparent.
For two independent means, like pain scores under two treatments, we need effect size, standard deviation.
For two proportions, such as adherence rates, we enter expected percentages in both groups with alpha and power. In paired or before-after designs, we base sample size on the standard deviation of within-person differences.
Later, we will walk step by step through numerical examples for means and proportions in allied health research. After we compute the ideal sample, we increase it slightly to cover dropout, refusals, and unusable data. In cluster or multi-center designs, a design effect inflates sample size because patients with enters.
A feasibility check asks whether your recruitment speed, staff, and budget can realistically support that planned sample. In protocols, clearly report design, outcome, effect size, variance, alpha, power, and